Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2016 Maths Methods Exam 2 suggested solutions. Like always, before I start this video, guys, if you guys want, tutoring in specialist methods, physics and chemistry, what you can do is pretty much you can email me through this email and we can have a discussion. What you will, I do private tutoring, and what you'll get a lot of perks. For example, you will get a dedicated Discord server with a lot of students, where, you will get thousands of past exam questions for specific topics. You'll also get a Q&A sections where you can, submit questions that you are struggling with, especially the hard ones, and I'll be there to help you with that. And yeah, guys, like always, let's start with these questions. Question 1. Let f be from 0 to 8 pi, f of x this, find the period and range. Easy. So we know that the period is 2 pi over, so it's half here, so just be 4 pi. Your range is, okay, look at this. There's a quick way to always find the range. And so look at the, translation first. And let's put that translation minus first the amplitude, which is 2. And do the same thing. So again, pi, now plus 2. So that will give us this over here, which is our actual range. Yeah, keep that as your range. State the rule for the derivative of f. So we want to find f dash of x. So let's go on our calculator and let's actually write this. So let's define f of x first as 2 cos x over 2 plus pi. All right, so let's do this. So f of x, and we get negative sine x over 2. Done. Find the equation of the tangent to the graph of f at this point. Nice and easy. 1 mark. I'm just going to use my calculator. Go on menu. Go on calculus. Tangent line of f of x, comma x at value of pi. And we get this, which is, we'd say, so y equals 2 pi minus x. Done. Find the equations of the tangents to the graph of f that have a gradient of 1. So we want f dash of x to equal 1 with a gradient. And we know that f dash of x is negative sine x over 2. So negative sine x over 2 equals 1. So x will equal, let's use our calculator. So we want to solve where this derivative over here equals 1 comma x for the domain 0 to 8 pi. So 0 x 8 pi. And we get these two values. Let's write that down. 3 pi and 7 pi. And let's just use our calculator to find the tangent. So tangent line, so go on calculus, tangent line f of x, comma x, comma 3 pi. That's 1, and the other one is 7 pi. Okay, write these two. Let's write them down. So we get y equals x minus 2 pi, and y equals x minus 6 pi. Done. The rule f dash of x can be obtained from the rule of f under the transformation t, such that this, find the value of a and b. Okay, so what they're saying is, the rule of f can be obtained. So we're going from f of x. So our f of x is what? Well, if I just have a look, f of x is 2. We're going from 2 cos x over 2 plus pi to the f dash of x, which is negative sine x over 2. So negative sine x over 2. Yeah? Perfect. So what I would do is I would actually expand this matrix. So it will be x dash equals x minus pi, and y dash is equal to ay plus b. And I'm going to solve for x, so it'll be x dash plus pi as your value of x, and this one will be y dash minus b over a as your y. Okay, so subbing these over here into this, we get y minus b over a equals 2 cos x dash plus pi over 2 plus pi. Now, let's just solve for y. So y equals, therefore, 2a cos x dash plus pi over 2 plus pi a, then plus b. So we get this over here. So how do we get this over here to the sine? Well, you should know your complementary angles here. For example, let's actually just simplify this over here. Let's really simplify this as x dash over 2 plus pi over 2. And we can see that this is a complementary angle. And you should know your complement. If you don't know your complementary, it's no stress. What you can do is you can use a calculator. For example, let's just go to our calculator and say, what does cos of, for example, this one's x over 2 plus pi over 2. So plus pi over 2. It gives us negative sine x over 2. Let's write that down. So this will just say, we can rewrite this as y equals 2a, there'll be a negative now, so negative 2a sine x over 2 plus pi a plus b. Now, this looks very similar to this, so now we can equate some coefficients. So we can say that negative 2a is equal to negative 1, so a is equal to half. We can also equate this over here to 0, because there's nothing over here. So we can say pi a plus b is actually equal to 0, and we know a is already half, so it would be pi on 2 plus b equals 0, and b is actually negative pi on 2. So these are your values. Your a is half, and your b is negative pi on 2. Hope that makes sense. Very nice. Find the values of x from this such that f of x is that. Okay, just let's write the equation. So we want f of x, which is just 2 cos x over 2 plus pi equals 2 times, it's negative sine x over 2 plus pi. Now I'm just going to use my calculator here to solve them. So x is equal to what? So we're saying we want to pretty much solve where f of x is equal to f of x, so the f dash of x. I have to also multiply that by 2 here. And then we want to plus pi, comma x. Given that x can only be from 8 pi. And enter that, and we get these 4 values. Those are your values of x. Let's write those down. 3 pi over 2, 7 pi on 2, 11 pi on 2, and 15 pi on 2. Done. Question 2. Consider the function f of x as this. Given that g dash of x is equal to f of x, and g of 0 is this, show that this is that. Okay, very nice and easy. So, we just need to integrate g dash of x to bring it to g of x. So what does that mean? It means just integrate f of x. So it means that g of x is equal to the integral of negative 1 over 3 x plus 2 x minus 1 squared dx. And we'll just show some working out. So this will be, what's the integral? Let's actually just define the new function for like f of x is now negative 1 over 3 times x plus 2 x minus 1 all squared. Okay, so we have this, and what we want to do is just to integrate f of x. So what's the integral f of x dx? It's this. So this integrates to, let's just write negative x3 minus 6x plus 8 over 12 plus c. So this is your g of x. Now we know that g of 0 equals 1. So 1 equals, so if I sub in 0, it will be, alright. So if I add 0, 0, 0, we get 8 over 12 plus c. So c is okay, 4 over, I don't know what I've done here to get Have I done any mistake here? I'm just going to make my life easier. Okay, I'm just going to expand this actually. Let's just expand this. So negative x4 over 12 plus 6x squared over 12, which is just half. So plus x squared on 2 minus 8 x over 12 plus c. Now this is easier to deal with, so if I sub in 1 and sub in 0 to all of them, c is equal to 1. Okay, now that it's easier to understand, yeah. So this whole thing is just g of x is negative x4 over 12 plus x squared on 2 minus 2x over 3, because this simplifies, plus 1. That took very long for a 1 mark. Wow, that's, yeah. Find the values of x for which the graph of g of x has a stationary point. Very nice and easy. So what I'm going to do is I'm going to solve for, well, actually, let's define g of x. So we know that g of x is what's written over here. So it's just pretty much, I'm just going to make, so I'm going to expand this, and I'm just going to plus 1 on it. And then I'm going to say that's g of x as defined by this. Let's find this g of x. So I want to find where g dash of x actually equals 0, comma x. And these are your values. So at x negative 2 and x equals 1. Done. Move on to the next question. The diagram below shows part of the graph of g of x, the tangent to the graph at x equals 2, so here, and the straight line drawn perpendicular to the tangent at x equals 2. The equation of the tangent at point with the coordinates 2, so this coordinate is 2, g on 2, is this, which is a negative gradient, so it has to be this over here, this green graph. Let's just make sure, write the equation, so y equals negative 4x on 3 plus 3. Okay, the tangent cuts the y-axis at B. The line perpendicular to the tangent cuts the y at x, C. Find the coordinates of B, which is, yeah, easy. So it's just 3, because it's the y-intercept of this. So it's just 0 on 3. Done. Find the equation of the line that passes through AC and hence the coordinates of C. So A and C. Okay, not too bad. So let's just label this as another equation, but this is perpendicular. We can see that they're perpendicular, so we can say that the gradient of the green graph, which is just negative 4 on 3, what's the perpendicular gradient? It's just negative 1 over negative 4 over 3, which is negative 1 times negative 3 over 4. So it'll be 3 on 4. So that's your actual gradient. So we can say, and it also passes through point A, so we can just say what's y minus g of 2 equals 3 over 4 x minus 2. And we can solve for y. So let's do that. So solve where y minus g of 2 is equal to 3 over 4 x minus 2, comma y. Okay, is that right? Yeah, it looks good. So let's write that down. So that'll be 9x minus 14 over 12. That's your equation. And hence find the coordinates of C. Very easy. So to find the coordinates of C, what we're going to do is... the coordinate of C is just a y-intercept. Yeah, so it's just subbing in 0. What is negative 14 over 12, which is just negative 7 over 6. So we can say that C is just 0, negative 7 over 6. That's that. Perfect. Find the area of the triangle ABC. So, okay, A, B, and C. So we want to calculate the area of this over here. This one, this triangle right over here. Nice and easy. So we know that the area of a triangle is half. Your base is this over here, this length here, which is, we know b is what? We know b is 3, so this is 3 plus 7 over 6. So 3 plus 7 over 6. And what's your height? So your height is from here to here, which is 2. Just point over here. So put that 2 in here. We know that these cancel out, luckily, so it's just 3 plus 7 over 6. So 3 plus 7 over 6 gives us 25 over 6. That's units squared. That's, yeah, area of a triangle. But tangent at D is parallel to the tangent at A. It intersects the line passing through A and C at E. So the tangent at D is parallel to the tangent at A. It intersects the line passing through ACE. Yes, okay. So find the coordinates of D. So what do we know? Well, these two have the same gradients, don't they? So we know that these two have the same gradients. So because we already know the gradient of line A, yeah, it's equal to the gradient of the other line. But so we know that line A is, no, the line here is -4/3. So we just want to find where G dash of X equals -4/3. And we can calculate the value of D where the x-axis occurs. -4/3, yeah. Perfect. So we want to solve where G of X is equal to -4/3 given value of X. Okay, so -1. So that value is -1. So then what's just G of -1? 25/12. So your coordinate is, so let's just write some stuff down. So X equals -1 and X equals 2. And what's then G of -1? It's 25/12. So D is just -1, 25/12. Done. Find the length of AE. So this length over here. Well, luckily, we know the coordinate of A is 2 on G of A. G of 2, sorry. And this coordinate over here is, we now know, we can find the equation of the line, this line over here. We can find the equation and let it equal to this line over here to find the point of intersection of here. Yeah, so let's do that, actually, yeah. So what I'm going to do first is, so let's say y equals, let's find a tangent, let's find this equation of this line over here. This equation of this line, so y equals what? So if I know that, if I go menu, calculus, tangent line of G of X, given that X is never -1, we get this nice equation. So let's write that down. So 3/4 -4x over 3. Okay, so we want to let this equation equal to this equation, which we should have calculated to this equation over here. So 9x minus 14. So 3/4. So we can say 3/4 minus 4x on 3 equals 9x over 12. Is it 9x over 12? Next, x equals 9x minus 14 over 12. So x should equal, so we're going to say this equation here equates to this equation over here. And we want to solve comma x. So 23 on 25. So that's 23, 25. And let's find the y value. Well, the y value we can just easily find by just taking one of those equations and pretty much subbing in this equation. So that'll be -143, 300. So now we have both the point. So now we can just use the distance formula. So we can say AE, the distance AE is just negative 143 over 300 minus G on 2 all squared plus 2325 minus 2 all squared, which gives us, let's do that, so this minus G of 2 all squared plus this minus 2 all squared, and gives us 27 over 20. So that's your length, 27 over 20. Perfect. Question 3. A school has a class of 22 new laptops kept in a rechargeable trolley. Provided each laptop is correctly plugged into the trolley after use, its battery recharges. On a particular day, a class of 22 students uses the laptops. All laptop batteries are fully charged. Okay? At the start of the lesson, each student uses and returns exactly one laptop. The probability that at the start of the lesson, the probability that a student does not correctly plug their laptop into the trolley at the end of the lesson is 0.1%. The correctness of any students plugging in independent of any other student's correctness. So we're using binomial because it's independent. Determine the probability that at least one of the laptop is not correctly plugged into the trolley at the end of the lesson for decimal places. So we want to calculate the probability that at least one. All right, so we know that X, we can say, is binomially distributed. Well, there's 22 students. There's also the probability that it's not plugged in is 0.1. So just use our calculator here. Just control N this and just create a new part here. Okay, so let's go in probability distributions. Binomial CDF. Number of trials is 22. Probability of success is 0.1. Our lower bound is 1, and our upper bound is 22. And it gives us this. Let's write that down. 4 decimal places, so that's 0.9015. Yeah. A teacher observes that at least one of the returned laptop is not correctly plugged into the trolley. Given this, okay, look. Straight away you should know that's conditional probability. This is where you start getting confused because they're giving you this rubbish statement. You're like, why do I need to know this statement? Like, a teacher observes that at least one of the returned laptop is not correctly plugged in. Like, it's not telling us to calculate the probability. It's just like a teacher observes that at least one of those things is. So they're giving us a condition, like a given condition. So that's where you should straight away realize that this statement's like quite not the same as the other one. So yeah, here they also give us the word given. So luckily it's conditional probability. So find the probability that fewer than 5 laptops are not correctly plugged in. So we want a probability that X, so that the probability that fewer than 5, so less than 5, given a teacher observes that at least one of the returned laptop is not correctly plugged in. So X is greater than 1. Now, because it's binomial, I can just rewrite this as X is less than 4. And that is all equal to, if I just draw a timeline here, say that's 1 and that's 4. This is going this way. This is going that way. So the intersection is 1 is less than X less than 4 all over probability of X is greater or equal to 1. So yeah, now let's just use our calculator. So what do we know? Well, luckily this is good, this statement. This is probably if X is greater than 1. Yep. So we just want to take this over here and say our lower bound is still 1, but our upper bound is 4. So we get this. So, and then what we want is this statement divided by this over here. And we get this over here. That's your actual probability. Let's write that down. For this places. So that's 0.9312. Done. The time for which a laptop will work without recharging the battery life is normally distributed with a mean of 3 hours and 10 minutes. Okay, now just making everything confusing. Just transform this all to actual minutes. Make your life easier. So 3 hours is what? So 6, 12, 18, 120 plus, like 180 plus 10, 190 minutes. So yeah, your mean is 190 minutes, and a standard deviation of 6 minutes. Suppose that the laptop remains out of charge trolley for 3 hours. For any one laptop, find the probability that it will stop working by the end of the 3 hours. So, okay, we can say that at least x is normally distributed now. So we can say normally distributed with a mean of 190 and a standard deviation of 6. So 6 squared. Okay, so that. Alright, so if I just draw a nice binomial here and say this is your mean, we want for any laptop, find the probability that it will stop working at the end of 3 hours. So this is 3 hours, which is 180. So yeah, we want to find this probability here. So we just want to find the probability that x is less than 180. And that's easy. Let's use our calculator. So just go on menu, go on probability distribution is CDF. So our lower bound is negative infinity, our upper bound is 180, and our mean value is 190, and our standard deviation is 6. And it gives us this. Let's write that down. 2 4 decimal places, that's 0.0478. A supplier of laptops decides to take a sample of 100 new laptops from a number of different schools. For samples of size of 100 from the population of laptops, the mean battery life was 3 hours and 10 minutes, and a standard deviation of 6 minutes. Let P be the random variable of the distribution of the sample proportion of laptops with a battery life less than 3 hours. Okay, which we've calculated here. And this one's less than 3 hours, yeah, so less than 180. Find the probability that this and that. Okay, so what I'm going to do is I don't like in this kind of form, so I like to transfer them back to like in terms of x, and we know that p hat is equal to x over n, and our n value is 100. So this over here, what's 0.06 times 100? It's 6, so we can just rewrite this as x is greater than or equal to 6 given x is greater than or equal to 5. Now it's much easier to use, so this is just equal to the probability that x is greater than or equal to 6 over the probability that x is greater than or equal to 5. And they're telling us to not use normal approximation, so what we're going to do is, yeah, use binomial. Now, let's say x is binomially distributed with a mean. So if I'm different this. Wait. We know that there's 100 laptops, and we know we know the probability of it less than 3 hours, which is calculated over here, which is 0.0478. And let's just use our calculator. So let me just copy this over here and just go menu, probability, distributions, binomial CDF. Okay, number of trials is 100. Your probability of success is this. Your lower bound is 6, and your upper bound is 100. Let's write that. The next one's the same, but our upper bound is 5. So 5 to 100, yeah, same everything. And we get this. So it's this divided by this. And that gives us control enter, and it gives us this. So let's write that down. That's 0.3 decimal places, that's 0.658. Done. It is known that when laptops have been used regularly in a school for 6 months, their battery life is still normally distributed, but the mean battery drops to 3 hours. So now, okay, it is also known that only 12% of such laptops work for more than 3 hours and 10 minutes. Okay, so they're saying it's probability. It is known that only 12% of such laptops work for more than 3 hours, and 10 minutes. So x is greater or equal for more. Wait. X is greater than 190. They're saying such laptops work for more than 3 hours and 10 minutes. So that is 0.12%. Find the standard deviation for the normal distribution that applies to the battery life of laptops that have been used regularly for school for 6 months, corrected for decimal places. Okay, now it's a typical question. So what I'm going to do here is I can rewrite this as 1 minus probability of x is less than 190 is equal to 0.12. And that's negative probability of x is less than 190. Negative 0.88. Because I've already net 1 in there. And that will give us the probability of x is less or equal to 190, 0.88. Now, using our calculator, now let's turn this into Z form. So we can say, x is just 190 minus your mean, which is 180 now, over your standard deviation, should equal what? It should equal, if you go menu and we go to actual probability distribution, and we go inverse normal, and our error here is 0.88, and everything looks good, and we get this. So we just want to now solve where 190 minus 180 is just 10, so we can say 10, and let's put this as O equals this value, comma O, and we get 8.5. That's your answer. So let's just write this. So that's 1.17, and so O is your standard deviation. 2, for the some places, that's 8.5107. The laptop supplier collects a sample of 100 laptops that have been used for 6 months from a number of different schools and tests their battery life. The laptop supplier wishes to estimate the proportion of such laptops with a battery life of less than 3 hours. Okay, so basically the supplier tests the battery life of the laptop one at a time. Find the probability that the first laptop found to have a battery life of less than 3 hours is the third one. Wait, what are they saying? Find the probability that the first laptop found to have a battery life of less than 3 hours is the third one. Okay, all right, so it means that, so they're saying the probability, like let's say he has 100 laptops, but he wants the third one to be less than, he wants it to be less than 3 hours of charge. So for example, if we have two, let's say these are laptops. So this is the first laptop, and we want it to have a charge greater than 180. He wants it to have a greater charge than 180, because his main point is he wants this one over here, the third one, to have less than 180, because we want the battery to have battery less than 3 hours. Whereas even this one has to be 180, so we want that. So it means just, it's the probability of x is greater than 180 times probability that x is again greater than 180 plus the probability, not plus, times, careful, because then it'll add up probabilities. Probability of x is less than 180. Is that right? And we luckily know that if our mean, so if we know that the probability of x is greater than 180 is our mean. Like our mean is at 180. So think of it like this. Our mean, if I draw a nice distribution over here, our mean value here is 180. So for this one, greater than 180 is just half, and less than 80 is a half. So it's just half times a half times a half, which is 1 on 8. Done. Wow, the wording is very confusing. Just, yeah, you have to read it carefully. 1 mark for that, wow. The laptop supplier finds that in a particular sample of 100 laptops, 6 of them have a battery life of less than 3 hours. Determine 95% confidence interval for the supplier's estimate of the proportion of interest. Very nice and easy. 1 mark. Just use your calculator. Go in menu, go in statistics, go in confidence intervals, 1 prop z interval. Our success is 6 out of 100 and 95% confidence. Okay, control enter. And here's our lower bound and upper bound. So let's write those down. To 2 decimal places, that's 0.01 and 0.11. Done. The supplier also provides laptops to businesses. The probability density function for the battery life x in minutes of a laptop after 6 months of use in the business is this. Find the mean battery life in minutes of a laptop with 6 months of business use. Okay, easy. So we just, yeah, to expect the value, we know is just what? It's the integral from 0 to 210 x times f of x dx. Let's use our calculator. Let's just define f of x. So f of x is 210 minus x times e x minus 210 2400. Okay, so we want this from 0 to 210 x times f of x dx. Control Enter, two decimal places, that's 170.01. Done. Find a medium battery life in minutes of a laptop with 6 months of business use. Nice and easy. So we know that the medium is from 0 to some value of m of f of x dx, and that should equal to half. So let's do that. So we want to solve when from 0 to a value of m, f of x dx should equal to 0.5 comma m. And our m value is, we get 2, but remember our domain, is it within our domain? Yeah, it's not, so we only get this one. This one's above 220, so it's only this one over here. So let's write that down. M is 176.45. Done. So perfect. Question 4. Is this the last question? It's a very long exam, dang. Wow, it's a lot. Wow. Still have more to go. Let's smash through this quick. Okay, let's do this. Question 4, express this in the form of this. Easy. So what I'm going to do is I can just go on Control N first. Let's Control N. What's the new question? So I just write expand. What's 2x? Oops, what happened? Wait. Expand 2x plus 1, x plus 2. Gives us in this form. Perfect, let's write that. So our a value is just 2. Oops. Is 2 plus minus 3 over x plus 2. Done. So let f of x be this. Find the rule and the domain of the inverse. And okay, that's easy. So one of the best ways what I'm going to do is, because it's 2 marks, so it just wants the domain and the rule. So I'm just going to go on solve f of y. Oops. Comma x, comma y. This is, ooh, what did I do? Oh, I didn't define f of x actually. Let's just define f of x as this, which is, yeah, that. So, and then that. Okay, this is here. Our actual, yeah, this is, let me just go and expand, actually. This is expand it. So this is our actual inverse. Let's write that down. So f inverse of x is -3, x minus 2, minus 2, and our domain is just the range of the original function. And our original function, what's the range? Well, it's all reals with the exception of 2. Done. Yep. Yeah, that's good. So part of the graph of f and x are shown in the diagram. Find the area of the shaded region, 1 mark. Okay, nice and easy. So integral from, we can see it's -1 to 1, and our upper function is f of x. So we'll say f of x minus x dx. That gives us this over here. So area is 4 minus 3 log E3. Parts of the graph of f and the inverse are shown. Find the area of the shaded region. Now you should straight away know that we calculated y equals x. So we just calculated this area. It's just doubling it. We should get the area of that. Yeah. So we can say area is 2 times 4 minus 3 log E3. So area is 8 minus 6 log E3. Part of the graph of f is shown below. Okay. The point C and D is on the point, so is on the graph, yeah? Find the exact values of C and D, such as the distance of the point to the origin is a minimum, and find this minimum distance. So we're saying this point over here to this point is a minimum. We know this coordinate is 0, 0, and this coordinate, let's call it x and y, x and f of x, because it'll make our calculations easier. So what we're going to do is we're going to just calculate distance. So distance formula in terms of x is just the square root of f of x minus 0, but then squared, plus x minus 0, so it's just x and squared, which is equal to, let's do that. So we're saying the square root of f of x squared plus x squared. And it gives us, yuck, this equation. Yeah, let's write that down. So x4 plus 4x third plus 8 x squared plus 4x plus 1 all over. Now that's absolute value plus 2, but we want to make sure, let's put that value in, so oops, x plus 2. So what's d dash of x? What's d dash of x? So derive, oh no, we just write d dash of x is equal to 0. Make our life easier, and then we can just solve it, yeah, for minimum. So what I'm going to do now is I'm going to do the quickest way, which is just go in menu and calculate minimum value of this function over here. So I want to calculate the minimum. Given that x, we can see is only between -1 and 0. And we get our actual value. Done. That's your c value. So your c value is √3 minus 2. And your d value would be, what's f of this value? 2 minus √3. So, and we just want to calculate the minimum distance, easy. So our distance formula over here, and we just have to put a value of x, and this is your distance. Your distance is 2√2 minus 6. Minus √6. That's that. Wow. Done. Alright, let's move on to the next question. Let g be from -k to infinity. G of x this, where k is greater than 1. Show that x1 is less than x2. Implies that gx1 is less than gx2. Now, I've seen this expression before. It's in the textbooks. I don't know, it's something of strictly increasing or strictly decreasing, this formula. So, it's probably telling us to use something, concepts of that. And where x is between these. Okay. So, I think this is, yeah, they're just trying to tell us about strictly increasing or decreasing. For 2 marks, what I'm going to do is to show that that is that. So we want to show that this implies this. Now, yeah, I'm going to, because this equation is the same as, but is the same as the, this one, where is it? This one, but 2 is that, but whereas this one's k. What I'm just going to say is I'm going to rewrite this into, I'm going to expand this form. So expand of k times x plus 1 x plus k. Okay. Oh, wow. That's not good. That's not good. Oh, no, it is. Don't worry. Just put these together because they have the same denominator. So it's just, we can write this as -k squared plus 1 all over x plus k plus k. So what does that mean? We have a y asymptote at k, and at x equals -k, we have an x asymptote. We also need to remember, how does the graph look? Well, look at this point over here. This one, how does this with this? Because of this negative, if I take that negative out and make my life easy, so if I take that, this will be negative, and I have to make this -1 now. So if I take that negative out, what do we know? We know that the inside function, so we know that k squared minus 1 must be greater than 0, because remember that k is greater than 1. Like, for example, what's k greater than 1? Let's say 2. Like k equals 2. So if we put 2, it'll be 4 squared. It'll be 4. 4 minus 1, it's always going to be greater than, yeah. So it's always going to be greater than 0. So imagine that this is positive, and we've put a minus over here. So it's going to look like the graph of this hyperbola. It's going to be the reflected, which is this. So normally it's like, y equals 0. Normally it's going to be like looking like this. Yeah. So for this one, let's just have a sketch of it. All right, so what I'm going to do is I'm going to say this is x and y. So at y equals k, and k is greater than 1, so let's say it's around this point over here. It's positive, so y equals k and negative k, so which is over here. Let's say that's x equals negative k, and the graph looks like, well, we don't know the y-asymptote because we don't know if it like, we know it looks like this, but we don't know if it would go like this or, so let's just draw like this. I don't know, like that. So what can we tell? Well, let's say we pick a point, for example. Let me just draw it nicely. Let's just draw it like this. Okay, say we pick a point. For example, x, like at this point over here, and this point over here. Say this point over here is, so show that when x is 1, so x1 is less than this. So let's say this is x1 because x1, this is x1, this is x2. So what it happens to the, so we know that this is gx2, and this over here is g x1. What can we see? Well, we know that gx2 is greater than gx1, which we can say gx1 is less than. So this statement holds true. We can see from this over here. So we can probably just, we have to write something. So we can just say, because the function is strictly increasing, we can say as g is strictly increasing from negative k to infinity. So as g is strictly increasing from negative k infinity. Alright, oh wow. How would we get marks of this? Let me just make this smaller so we can write some stuff. Okay. Let's write this over here. So as g is strictly increasing from negative k to infinity, we can see that x on 1, so as g is strictly increasing from negative k to infinity, given that x on 1 is less than x on 2, x1, so g, oh my god, as g is strictly increasing from negative k to infinity, given that x on 1 is less than x on 2, g of x on 1 is less than g of x on 2 for x is an element from negative k to infinity. As g is strictly increasing from negative k to infinity, given that x is 1 is as shown on the graph. Look, not gonna be honest, this question is, I don't know how you would you can do algebra, but I don't think algebra would be the best here because 2 marks doing algebra is a pain in the ass. So yeah, hopefully this should give you a mark or 2. But yeah, like you've drawn the graph, you've shown how g of x on 1 is always going to be less because this is a strictly increasing function. So yeah, so as g is strictly increasing from negative k, given that as shown in the graph, yeah, it should give you the mark. Let x be the point of intersections of the graph of g of x and y equals negative x. Find the coordinates. Okay, so we just want g of x to equal negative x. Alright, so let's solve where g of x, we haven't defined g of x, so g of x is defined as this over here, isn't it? If I go up. Yeah. So coming down over here, we're just saying g of x equals negative x, so we want to solve answer, comma x. And we get these two here. But remember, we want to take the positive because k is greater than 1. We're taking it on the right-hand side. So be careful. Don't use that negative 1 over here. So we're going to use only 1. So x is k squared minus 1 minus k. And your y coordinate is just, so your y is just negative of, because we're just using this, so negative k squared minus 1 minus k here. So your coordinates are overall negative k plus k squared minus 1 and k minus k squared minus 1. Done. Yeah, that's your x. So find the value of k for which the coordinates have this. Okay, so let's just take this over here. I'm just going to take one of them, like this. And I'm just going to equate it to this negative half over here. And I'm going to solve for k in my calculator. So solve this over here, this expression over here, equals negative 0.5, comma, k. So k is 5 over 4. Now 5 over 4 is greater than 1, so that makes sense. And it says find the value of k, not values. So yeah, looks good. Let's see this point. So here, which is negative 1 on 1. Negative 1, negative 1. Let y equal this point here. 1 on 1. And x be the vertices of the triangle xyz. Let sk be the square of the area of the triangle xyz. So this over here, this rectangle, triangle, the square of the area is the function s of k. Find the values of k such that s of k is greater or equal to 1. Now, now we're going to use the formula of a triangle. So we know that the area of a triangle is half. Your base is, for this one, it's just this base over here. Now, we know that this is 0, 0. By just using the distance formula, we can calculate the distance of this over here. So, yeah, so like 1 squared plus 1 squared is root 2, just root 2. So, if this is root 2, this is also root 2, because of the, it's negative 1. So the overall length is just 2 root 2. 2 root 2 of this whole thing. So we can say 2 root 2. So we put, 2 root 2. Now, what do we know too? Well, we can see that just from this. To find the coordinate of the height, we know that's 0, but we just need to find this coordinate over here. To do that, I know for a fact that the line y equals negative x, which we did over here, didn't we? Yeah, y equals negative x. So we've calculated the intersection point, which we've already calculated. So if we, which is over here, and it gives us our x value, we know we can use this, where is it? This coordinate over here. That's our x. So it means that we've already calculated the coordinate of x. So it means that to find the distance of this line, it's just going to be the square root of the y-intercept of it squared. So k minus root k. So k minus. Sorry. K minus root k squared minus 1 all squared plus negative k plus k squared minus 1 all squared. Is that right? Yeah. So that gives us the area. So area is, let's write that all down. Using our calculator, so half 2 root 2 times the square root of the y-intercept, which is the negative. So like negative this over here. Put it in here. Because that's going to expand and that's going to give us a y-intercept. And we just want to, so that square root, oh my god, so that's your y, wait, yeah. Okay, now this is too confused. What have I done? Okay, so, square root, let's write it as what we did. So k minus square root k squared minus 1 all squared plus this over here all squared done. Anytime we get this, let's write that down. 2 k minus k squared minus 1 squared. So now what I want to do is I want to square it, because remember it is s of k is the square of the area. So answer square, I want to square this, and I want to let this be greater than, so we're going to solve where this function over here is greater or equal to 1, comma k, given that k is greater than 1. K is greater than 1. Anytime we get this, let's write that down. So k can be between 514 and 1. That's that. I hope that's right, man. That's a lot of, wow, that's a lot of working out. So the graph of g in the line y equals x. Yep. Enclose the region of the plane. The region is shown shaded in the diagram below. Okay. Let a curve be the rule of the function a. That gives the area of this enclosed the domain of a is 1 to infinity. Give that rule for a of k. So the area, so we know that a of k is the integral of, from -1 to 1, of the upper function, which is g of x, minus x dx, as we can see. So let's solve that. So area -1 to 1 g of x minus x dx, and we get, wow. Okay. Guys, just be careful. Let's just write, to be safe, because all these absolute value things are not good. So let's just write k is greater than 1. Now it's a nice equation. Yeah. We have to always specify that k is greater than 1. So let's write that down. So a of k is k squared minus 1 log e k minus 1 over k plus 1 plus 2k. So show that the area is between 0 to root 2 for all values of k is greater than 1. Alright, so what I'm going to do is I am going to so what am I going to do is so I'm going to go on my calculator and just actually graph g of k, yep, and x. Let's graph them, and we know that k is greater than 1, so be careful. Let's make sure that's like 1.1, and this 5. So okay, so we can see, yep, that area is what we actually, that's a of k right there. And it's saying show that the area is between 0 and root 2 for all k is greater than 1. So, well, what do we know? Well, of course, the area is going to be greater than, as we can see, like if we put this to, let's say, 100, like you can see that there will always be an enclosed, like, as you may not even see it. If we zoom in, you need have a look at this. So it's saying that, okay, we're saying that when, have a look at this. So we can always see that there's an area bounded, and even if we increase the value of k to infinity, what can we see? You may not, it will always have, there will always be an inclusion inside there. There will always be an area, but we can't really see it, as we can see. But yeah, so we need to prove that, yeah, that the area is only between 0 and 2. So the max is then 2. So let's do that. So if I put this number here to like 0.01, and let's say this is 1. Oops. Not 1. 2 actually. What can we see? Let's have a look. See, as we get less and less and less, what's happening? You should see that this over here, the area enclosed, is actually becoming a triangle, a right angle triangle. And we should, let's say if we put it like very, very small, like 0.001. Let's get it to that very small. it's becoming better, like a more not refined triangle, a right angle triangle. So if I just put this now as like 1.001, and let's put this back. Oops, what happened? Yeah, as you can see, I mean, this is not even good, but it should be a perfect... Sorry, guys. Yeah, my video just stopped. Yeah, so it should be a perfect right angle triangle as it can be seen over here. So, yeah, as k gets closer to, 0, like, as k is greater than 1, we can see that the least value it can go is the area can become... It can never equal 0, by the way. It gets closer and closer to 0, as we saw as, as this goes, yeah. And what happens as k gets smaller and smaller to not like equal 1, as k is like not k is not greater than 1 but very close to 1, we can see that the area becomes a right angle triangle. So what is the actual area of this triangle? So let's just find it out. So we know that the area of a triangle is half. So what's the base? Well, the base is from, you should know that's 1, -1, and that's 1, so it's 2. And the height is also 2. So your actual, these cancel out and it becomes 2. So the area of that triangle is 2, which makes sense. It can go to a max of 2. And yeah, so how can we rewrite, like write a thing over here? An expression to explain this for 2 marks. So we can say, as the area enclosed by x, y equals x, and g of x, the upper function, so we can say the upper function, which in this case is g of x. So as the area enclosed by y equals x and g of x, the upper function the upper function g of x, wow, this is actually certainly hard to write because you need to write it very nicely to get the marks. What can we write? As the area enclosed by y equals x and g of x, as the area enclosed by y equals x and g of x, the upper function g of x is greater than x, we can see, from x, so we can say from x is an element from -1 to 1, and so yeah, and a of k, so the area is always greater than 0, as we can see. It never actually becomes like as we see, as a of k is great, so as a k, we know that a of k, the area is greater than 0, and what can we say? And a triangle can be formed. So as the area enclosed by y equals n g x, the upper function g of x is greater than x from x is number, and a of k is greater than 0. And a triangle can be formed with the lines, what can we say with the lines? X equals -1, y equals x, and y equals 1. The area of the triangle is 2, meaning that a of k cannot equal 2 but approaches it. Wait, so meaning that a of 2 cannot equal 2 but gets closer to it. Hence, a of k must be, so a of k must be less than 2. I think I'm just mumbling right now What the hell ever? Okay. As the area enclosed by y equals x and g of x, the upper function g of x is greater than x. Makes sense. From x elements from -1 to 1. And a of k is greater than 0. Of course, the area is greater than 0, as we saw. If we, have a look over here again, let's have a look again. What can we see? We can see that, let's put it back. Let's say put this back to 2. Okay, we can see that as we, increase k, what's happening? Well, we still have an area enclosed, but as we get closer and closer, let's say to, we will still always have this area enclosed. Now, it looks like it's becoming the g of x is becoming y equals x, but that's no, absolutely. We can still see a slightly area enclosed, so it will never actually approach 0. It gets closer to 0, actually. It's very close to 0, but will never actually equal 0. So that's why we would say that. And a triangle can also be formed with the lines x equals -1. Yep. So if you go down here, and say that was 1, let's say put that 1. Oops. 1. Oh, what's happening? Not 1. Let's put 2 here. What happens? So if we decrease this, it's becoming a right angled triangle, as we can see. So with x equals -1, y equals 1, and y equals x. So we've written that the area of the triangle is 2, meaning that a of 2 can never equal 0, but gets closer to it. Hence, a of k must be less than 2. Okay, I think that's a reasonable, explanation. But yeah, I'm not like, I don't like this exam. I find this exam to be one of the most ugliest exam because it's too much writing. Now it's not like maths. It's just explain this, explain why this is that, proof this is that. Now this is, it's too much. I feel like they've done that. It's not good. I don't think it's a good way to, I hope you guys enjoyed this video and learned something through it. And I hope you guys have a good day. Take care of yourselves and have a good day. Bye.